Hi, I'm Arnaud from BitCraze, and since the Loco positioning system has made great progress since our last video, we thought we'll make a new one to show you how to go from the Loco positioning system Indoor Explorer bundle up to getting one Crazyflie to fly autonomously. So to do so, I will be basically following the wiki page, Loco positioning system. We'll have a link under the video and advise you to look at it because the video will be there and maybe there is a new one because things are moving quite fast. So I will be using Indoor Explorer bundles, so that's 6 node, 1 deck, 1 Crazyflie and 1 radio. So that's what you get from us. And then I will also be using one Ubuntu 16.04 computer with ROS Kinetic installed and Xbox compatible gamepad. Ubuntu and ROS is the way we run the system right now. We will extend it to run with other software, but right now that's what works. So the first thing would be to update the anchor. So the anchor comes pre-programmed with a firmware which is a couple of months old now, and it's required to update them to get the latest and greatest. So to do so, I cloned the anchor firmware project. And make it. And I will put the anchor in DFU mode by pressing the DFU button and then resetting, and then releasing the DFU button. This way, it's in bootloader mode to be able to flash it from USB. And from the PC, I can make DFU to flash the anchor. After that, I will need to set the address of the anchor. So far we have the address from 1 to 6. And that's how the Crazyflie will address and communicate with the anchors. So now that it's flashed, we can reset it. It is recognized as a serial port. So we can look at what serial port it is, TTY SAM3 on my PC, so I can access it. There it is. When we connect to it, we get some information about the self-test. We see that everything is OK. And pressing A1 allows me to set it in Anchor 1 mode. And when I reset, now this is Anchor 1. So now that the anchor is programmed, next thing is to flash the Crazyflie. So we have a Kalman filter has been implemented by Mike Hammer at ETH Zurich. And this Kalman filter is not enabled by default in the Crazyflie firmware yet. So we need to pull the project, the Crazyflie firmware project, and compile it. But first, we need to edit the file tools in tools, make config.mk, which is a build configuration file to enable the Kalman filter. So this is documented in the wiki. You can copy-paste the required configuration. And then we just make clean and make to make the new firmware. To flash the firmware of the Crazyflie, we set it in bootloader mode. And since I have cloned the Crazyflie client, in the same folder I have my Crazyflie firmware and everything is installed, I can just make cload, and the Crazyflie is flashed over the air. So now that both the anchor and the Crazyflie are programmed, we need to install the anchor in our flight environment. What we've done here is that we've set up 3 anchor on the top, 3 anchor on the bottom. So 3 on the ceiling and 3 on the floor, which is good to have X, Y, and Z accuracy. And then we need to take measurement of the position of the anchor in X, Y, Z. So you need to choose an origin. So either one anchor will become 0, 0, 0, or as we have done here, one corner of the room is 0, 0, 0, and then we have one wall for X, one wall for Y. That allows us to measure fairly easily this position. And this position needs to be written down so that we can set them up in rows later. So the computer should have ROS installed, and the Crazyflie driver made by Wolfgang in USC needs to be installed as well to communicate with Crazyflie, as well as the LPS ROS module that we've made here at Bitcraze. And the anchor position needs to be entered in the anchor post.yml file in our LPS ROS module, in order for ROS to know where the anchor are. And when we connect the Crazyflie, the anchor position will be uploaded in the Crazyflie so that the Crazyflie knows where the anchor are and can position itself. So once everything is set up, we can try it. So we have a test line in the wiki that would launch ROS with everything set up, connecting to Crazyflie, and showing us its position. So we can start the Crazyflie. The front must face X. That's very important upon startup so that it knows its orientation. And then I will just copy-paste the line and change for the radio address for my Crazyflie. Mine is 72 mega. And we change also when we want to fly, where we want to fly. In my room, I would like to fly at 4.4 meters from this wall and 1.2 from that wall. So it's 4.4 in X and 1.2 in Y. And about 1.3 meters would be good to fly at. So I can launch it. Now, we see that the way it's implemented right now, when we upload the anchor position, there will be a small time until the position is stable. But now we can see that we see the anchors that are stuck in my system, so they are on my right here, and the copter is on the left of the system, which makes sense. And if I move the copter, then the green square that represents the copter will move. So then the next thing to do is to put the copter roughly below the wanted set point, press the blue button for takeoff, and here we go, we have an autonomous Crazyflie. So thanks for watching. Stay tuned for new video because lots of things are happening with local positioning systems, so we'll certainly make new videos soon. If you want more information, you can register to a local positioning system mailing list, and in any case, you can visit bitcraze.io for more information. Thanks.